continuing through PO7. We talked about this yesterday, combining like terms and the distributive property. We kind of left off there. Just a quick review of combining like terms. We are looking to simplify the equation to get it to be a two-stepper, right? Because two-step, that's our safety net, that's our comfort zone. We feel warm fuzzies when we see it because we know exactly what to do. So, without doing the whole thing, just a brief review. What would we do in this first one to combine like terms and simplify? What can be combined and what do we get as a result? Damien?
9x minus 4x.
Yes, the 9x and the negative 4x. Remember, we talked about a coefficient as saying how many of the variable we have. Right? Whatever x is, we have 9 of them. We subtract 4, we are left with 5 of them. And so we get the two-step equation, 5x plus 3 equals 43, subtract 3, divide by 5, blah, 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 and we can solve for x. Okay? Second one, what can we combine and what do we get? Peyton. Wow. Don't know where that came from.
You can do 8n minus 11n.
Yes, 8n and negative 11n. Even though they're not right next to each other, because we can add or subtract things in any order, we can still combine them. Just don't forget, it's a negative 11. That subtraction sign belongs to the number. So 8n minus 11n is negative 3n, plus 2 equals 29. There's our two-step, and we can go from there. Okay? Last one, what can we combine? What do we get? Henry?
We can combine the two n's and the two regular
Constants, right? Yeah, so we have negative 10n, negative 2n. What does that combine to be? Negative 12n, negative 10 minus 2, negative 12n. And then also these constants, positive 7, positive 3, give us positive 10, and then we can solve it from there. Again, that two-step equation. Okay? So the goal of combining like terms is to simplify the equation to get that two-step, right? Then, distributive property. Whenever you see parentheses, you should be thinking distributive property. And this is true for regular equations just like this. This will be true when we get to exponent rules in our next unit. When you see parentheses, you're going to want to distribute the power. This is true when we start multiplying polynomial expressions, not until PO7, okay? But it's a theme in algebra. When you see parentheses, be thinking distribute, right? So, let's just do this first one. We did the first one together yesterday. Well, let's pick it up here. What do we distribute? What do we do? What does that mean? To distribute something. Emerson?
To eliminate parentheses.
Yes, and so how do we, like, the actual act of doing it?
You times the 7 to the 3.
Yep.
And then the 7 to the negative 5.
Good. 7 times 3x and 7 times negative 5. We have to do this because order of operations says do the parentheses first, but we can't. We can't combine those, right? One has an x, the other one does not, and we don't know what x is. So we distribute to get around that. So 7 times 3x is 21x. 7 times negative 5 is negative 35, and that equals 7, and we once again have our two-step equation. We solve from here. This is where we left off. So from this point forward, we'll do much more thorough notes. We'll talk about things in more detail, and we'll get through this and then get to variables on both sides as well. This is the third type of multi-step equation. In this second one, what are we going to be distributing here? Think order of operations. It's tricky. Think order of operations. What is going to be distributed into the parentheses? Kaylin, what do you think? Oh, well done! Negative 2. Why can't we take 7 minus 2 and distribute 5? It's so tempting. Because it's right there. 7 minus 2 is 5. Let's put that in the parentheses. Why can't we do that? Jude?
Because the order of operations.
Says we have to do what?
Multiplication.
Multiplication.
We have to multiply before we subtract. If we do this subtraction before we multiply in the negative 2, we've broken the order of operations. So, what happens is this negative 2 is what goes into parentheses. The 7 just drops down because we haven't used it yet. Right? What we get from putting in the negative 2, negative 2 times n is a negative 2n, so it becomes 7 minus 2n. And then negative 2 times negative 6 gives us
Well,
positive 12. So it's going to become plus 12.
sure.
So this is a situation where not only do we have to distribute, but now we have to combine like terms, because we're not to a two-step equation yet. Okay? But all that changed was this right here. Distributing in the negative 2, the 7 just drops. We get negative 2n, positive 12. The 39 didn't do anything with that either, so that drops down as well. Okay? What can we now combine? Lauren?
I thought we were supposed to, subtract 12.
So we can start operations here if we want to, but we're not quite to that two-step yet. We want to make it our goal to be consistent and get to that two-step equation. So what can we combine to get that two-step? What are the like terms? The 12's involved,
7 and 12.
7 and 12, right? Positive 7, positive 12. Our equation becomes negative 2n plus 19 equals 39, and I just got chills because we have a two-step equation. I know exactly what to do from here.
Wait, I was so beautiful.
Exactly what to do from here. What do I do?
I was gonna say, why wouldn't it be 19 minus 2n?
Would that make a difference? It was 19 minus 2n
No,
versus,
no.
no. The reason why I put it like this is because when we start using slope-intercept form consistently, y equals mx plus b, that variable term is going to come first. You'll be used to working with equations with the variable term first and the constant second. Technically, this is what's called standard form of an equation. It's the proper way. YouTube can't see this, but I'm using quotes. Proper way to write it. If you did put the 19 first minus 2n, it wouldn't make a difference. Just look at the same value for n. But what do we do? Start with addition, subtraction, do the opposite. What does that mean? Subtract 19 from both sides. We get negative 2n equals 20. And then, Gabe,
You divide the negative 2.
divide both sides by negative 2. And we get n equals negative 10. Which if we wanted to check that, right? If we wanted to check that, we've got 7 minus 2 times negative 10 minus 6. And we want this to all equal 39. Well, negative 10 minus 6 is a negative 16. Negative 2 times negative 16 is positive 32. And then the positive 7 would bring us up to 39. So it does check out. And if you put this in your calculator exactly as you see it here, it'll do the thing for you, and you will get 39 as an answer. Questions on that one? Okay. The last one. 3t minus, in parentheses, 8 minus 2t equals 12. What are we distributing into the parentheses? Henry.
3t.
Ooh, not the 3t. Why not the 3t? And if not the 3t, then what are we doing? Go ahead, Lucas.
Negative 1.
Why not the 3t first? Let's answer that first.
Because the 3t is right next to the parentheses.
Right. The operation between 3t and our parentheses is not multiplying. Right? Negative 2 right up against the parentheses, multiply. The 7 right up against it, multiply. In this case, this 3t is separated by the subtraction sign. And Lucas, what'd you say we're actually going to be putting in?
Negative 1.
Negative 1. 1 is oftentimes a hidden number in math. My poster in the back talks about hidden math stuff, and a lot of that has to do with the number 1. Like 10 is actually equal to 10 over 1. We don't write the 1, but it's there. X is actually equal to 1x. We don't write the 1, but it's there. Bottom left one. A number by itself is actually the same as that number to the first power. We don't write the 1, but it's there. Okay, 1 is a very hidden number here. So yes, what this actually is a coefficient, I'll write it down here, a coefficient of negative 1 in front of our parentheses. So what gets distributed is that negative 1. Our 3t drops, just like the 7 did. We didn't use it yet. In distributing negative 1 into parentheses, all it really does is it changes the sign. Negative 1 times 8 becomes negative 8. Negative 1 times negative 2t becomes positive 2t. And then that equals 12. Okay? Questions on what just happened there?
No.
Pretty magical.
It was magical.
Sometimes when you watch a magic trick, you're left like, how did that work? How did that happen? Well, this is pretty magical. What we just did there. So if you missed it,
Wow.
I will explain.
Wow.
All right. So now, what can we combine?
3t.
We're not to a two-step yet.
3t plus 2t.
3t and 2t, which 3t and 2t give us 5t. And bless our lucky stars, we know exactly what to do because we are now at a two-step equation. Start with addition, subtraction, do the opposite. We're going to be adding 8 to both sides. 5t equals 20. Divide both sides by 5 and t equals 4. Okay? Now, technically, you did all this last year, right? This was PO61, Kyle. This was PO61. You've done this before, but I don't think you had a lot of equations like the two that we just did. This is the next level stuff. Last year was pre-algebra. It was preparing you for now what's being done here. Kyle? Shh. Henry? Shh. Okay, go ahead.
We did like the first question a lot.
Yes.
A lot of those, but we never did like the last one.
Correct. Yep.
Well, we did combine like terms and doing those two equations. So putting those two together.
Eddie? Okay. Questions on what you just saw here? Okay. The third type of multi-step equation is variables on both sides. And this gets confused with combining like terms a lot, because in combining like terms, you've got two variable terms or two constants that you put together, you simplify. Okay, but the difference is, in combining like terms, notice where your like terms are. 9x, negative 4x, on the same side of the equation, the same side of the equal sign. 8n, negative 11n, the same side. 7 and 3, negative 10n, negative 2n, the same side. When you have those variables on opposite sides, on both sides of the equation, your process is a little bit different. What are we going to use to move, not simplify, but move our variable terms to the same side?
Opposite operation.
Correct, sir. The goal is to move variable terms to the same side using opposite operations. I used to call it ops until op became like a bad word.
No, but me and
Not
you
bad
still
word
call,
necessarily,
me and you
but-
still call it ops though.
True, valid.
What about sad? Why don't
Thank you, Peter.
just saying sad first?
Opposite.
That's my cousin. Do you know Peter Hart?
I do not.
Okay.
I know Peter Cottontail, but not Peter.
Don't know your contents.
Mr. Schultz, if you said opposite ops, then
Opposite.
would mean different.
Don't mean opposite.
So,
Yeah.
looking at this first one, 16x minus 5 equals 12x plus 23. We see those two variable terms, but we also see they're on opposite sides of the equal sign, right? Meaning we can't combine them to get 28 because they're not. We can't simplify if they're on opposite sides. We have to move them using opposite operations. Doesn't matter which side we move the variables to. It doesn't. Okay? You can move your 12x's over to the left, or you can move your 16x's over to the right. Just to stay consistent, let's all do the same thing here. Let's move our 12x's over here. Okay? So if that 12x is positive on the right, what are we going to have to do to move it to the left? Grace? Subtract 12x. We don't want to divide by 12 here because division would separate the 12 from the x. Right? We want to move all those x's over, all 12 of them over. Okay? And so 16x's take away 12x's is 4x. The -5 drops. On the right side, we had 12x's, we took away 12x's. Now we have 0 x's there, right? We moved them all over. There aren't any x's over there anymore. And so the 23 drops, and lo and behold, our life just got better because we have a 2-step equation. Okay? Variables on both sides, it looks complicated, but one step, moving that x term over, and now we're in our comfort zone. Okay? Another way to look at this that some people like really glob onto this, and others are like, I don't get it, which is totally fine. If you look at your number of x's on the left and your number of x's on the right, how many more x's are on the left to start with? 4. It's not a coincidence that we have a 4 here, right? Those of you that play sports, basketball is probably the easiest to relate to here. If the score is 16-12, okay, your coach calls a timeout, he or she might say, all right, we're ahead 16-12 right now. Or they just might say, all right, we're up by 4. Right? It doesn't really matter what the score is necessarily. It could be 16-12 or 100-96. You're still up by 4 either way, right? So if you think about it as like a basketball score, and say, all right, we've got 4 more over on the left, it's, like I said, not a coincidence that that coefficient is a 4 there. Anyway, 2-step equation, what do we do? Let's finish this out. Addie.
You add 5 to get rid of 5, and add 5 to the 23, which will get you 28, and then 4 divided by 4 cancels that out, and 28 divided by 4 is 7.
Okay? Now how would you check something like this? How would you check something? It's a little more of a process than the other ones, I will admit that, but how would you check it? Grayson.
Would you just plug in 7 for all the x's?
You would. So I'm going to do it way up here. I have more space here. But we would plug in 16 times 7 minus 5. And we would want to see if that's equal to 12 times 7 plus 23. Okay? Well, 16 times 7 is 112. Minus 5 is 107. 12 times 7 is 84. 84 plus 23 is 107. We're looking for the value for x that makes the equation true. And 7, we plug that in for x, it makes both sides the same. This is where it starts to get difficult to guess and check. Right? Because you're not just solving for a variable, you are, but you're looking for what number makes both sides the same. That if you're just guessing and checking, it makes it difficult. So we really want to use the process, the opposite operations process, to get down to the answer. Okay? The next one. Negative 8n plus 8 equals 5n minus 18. This time, let's move our variables to the right side. Let's move our n's over here. If we have a negative 8n and we want to move it, what are we going to need to do?
Plus 8.
Blakely.
Add 8 on
Add 8n to both sides. Negative 8n plus 8n is 0. Cancels out. Leaves us with 8. 5n plus 8n is 13n. And the negative 18 drops. Oh, I'm in love. A 2-step equation. Okay? Using our basketball score analogy, you can't score negative points in a basketball game, but if we have negative 8n's over here and 5n's over here, how much greater is positive 5 from negative 8? Think temperature. If it's negative 8 degrees outside and the next day it's 5 degrees, how much greater is the temperature when it's 5 degrees? 13, right? It's not a coincidence that we have a 13 over here. Okay? So if this whole moving opposite operations thing seems to be a little bit not quite grasping it, if that makes more sense to you, use it. Okay? But here we go. What do we do first? 2-step equation. Patty.
First you gotta add 18 to cancel out the 18, and then you add 18 to the 8, which will give you 26, and then cancel out the 13n by dividing it by 13, and then divide 26 by 13. That gets you 2.
And we get 2. Okay? And we get 2. Alright, questions on variables on both sides?
Yes.
Because there's one more twist, one more plot twist I have yet to show you that Paul still has to. Gabe?
I already did them.
Yes.
I already did them.
What'd you come up with?
I got y equals 30 for the first one, and I'm just finishing this next one.
Well, stop, because you're wrong.
Really?
Yeah.
Sucks.
Yeah.
It's
So,
impossible.
there's, folks, there's a quirkiness with variables on both sides that you might run into. And if you look at what's going on in these last two, they both have something similar here. What is similar about these last two, Grace? Right. In the first two, we had a different number of variables on both sides. In these last two, it's like our score is tied. 9y minus 12 equals 9y plus 18. We have 8 n's on both of them in the last one. So if we move our 9y's over from one side to the other, which if we follow this process, what would we have to do to the 9y here to move it over? Subtract it, right? It's the opposite of a positive 9y. So minus 9y, minus 9y. Here it cancels out, and over here it also cancels out. Uh-oh. Okay? Hold up. And what we're left with is an equation that tells us negative 12 is equal to 18. Okay? Shh, James, how did you get something different?
I got y minus 12 equals 18.
Well, here's the thing. If you have 9 y's and you take away 9 y's, how many y's do you have left?
None.
0 y's. None y's. No y's. They're all gone. Okay? So, in no universe is negative 12 the same as 18. So I've heard some people say it. What would your solution be to this one, Christian?
No solution.
No solution. Okay? When your variables cancel out,
Oh, I just wrote y equals 0.
We had a no solution on the entrance exam, right?
you did not. No, you did not. If there is no solution, if you have this untrue equation, negative 12 is not equal to 18. When your variables cancel out and what's left is not true, it's no solution. The mathematical symbol for no solution is a 0 with a line through it. You can't put y equals 0 because 0 is a value. It represents no value, but it's still a number. Right? You can't plug 0 into this equation and make it true. Because if you do plug 0 in, you get negative 12 is equal to 18, which is not the case. Right? So the special type, we've got those variables on both sides like that. If your equation's untrue, it's no solution. Look at the fourth one here. What's going to happen to our 8 n's without even doing any of the math of moving them? What's going to happen?
Solution.
They're going to cancel out. What are we left with on the left side?
2 plus 5
Which is?
7.
What are we left on the right side?
7.
Does 7 equal 7?
Yeah.
So is this no solution?
No.
No.
Bro.
Okay?
It's 7.
This pencil is
Hey, folks,
Anything you
quiet,
want.
quiet, please. Quiet, please. Lucas, I need your hand over here, man. Okay, Kyle, stop talking to him. Okay? When you have a true equation after your variables cancel out, Lucas, what does that mean?
N equals anything you want.
Anything can work. Think about this. If we simplify this left side by combining 2 and 5, we get 8n plus 7. And on the right side, we already have 8n plus 7. No matter what we plug in for n, if we add 7 to that, it's going to be the same thing every single time. Versus this one, what do we plug in for y, 9y's, if we subtract 12 on one side but add 18 on the other, That's not gonna work. That's why it's no solution. For this one, it can be anything you want. Your equation is true, 7 does equal 7. So this is gonna be all solutions. And the mathematical symbol for this one, watch me carefully here, you kind of make an 11, and then you make an R by starting at the back vertical line, connecting it to the front one, and that stands for all real numbers, all real solutions.
We kind of put
That is not real.
N does not equal infinity. If you put infinite solutions, that would work.
Can I
Okay?
just put IS?
What does IS stand for?
Infinite solutions.
All solutions or all real numbers are what you want to put down.
Can I put IRS?
So N equals
All
IRS.
real-
Can I put N equals 7?
Okay, we only have about 5 minutes left. I need to run through what your homework is going to be. Christian, do you have a question? Or Asher, do you have a question?
All real solutions, does that mean zero, all real numbers, does that mean zero?
Zero's a real number.
What is the real
Have
number?
zero.
Hey, hold on. What?
Oh, I see.
Yes, 0 would work here. Okay, your assignment for tomorrow. We are going to skip this section here, and we're going to go on to part 2. I would like you to do the first page. There are 12 of them. Okay, the first page of PO7 part 2.
That's the homework?
Just the first page of PO7 part 2.
And then the back page of this.
Just the first page of PO7 part 2.
We have to do part 2?
Just the first page of PO7 part 2. There are 12 equations on there. Some of them are combining like terms, some are distributive properties, some are variables on both sides. Your work must be shown. If you do not show work, you do not get credit on this assignment. So make sure you show work. What's your homework?
Just the page of
Just the first page of PO7 part 2. Make sure you are showing work. Questions, comments, concerns, complaints, comments, congratulations,
I have a
criticisms?
question.
The bottom one's equal.
What? Okay. Grayson.
Would you rather listen to Taylor Swift or a raccoon eating garbage?
Taylor Swift.
eating garbage.
Taylor Swift. Lucas.
Raccoon.
Would you rather eat a chair or the smartboard?
Eat a chair or eat the smartboard? I suppose a smartboard. I feel like this would be kind of
Or
chewy.
listen to an alien singing just the two of us.
Oh, that's a bad.
That's a banger.
Listen to the aliens sing, just the 2 of us. Last one, James.
Never mind.
Very well. That's how you math.
Okay.